let me go now to Michael McDonnough. And what I want to do is do kind of a brief introduction. So Michael McDonnough, he was here last week. He's going to be talking about beta voltaic cells, which work on the principle of stimulated nuclear beta decay. When a beta decay event happens, a high energy electron is released, which can be captured and used to create a small high voltage current. So in the model he's going to be talking about, the high voltage electrical charge from beta events stimulates further decay events, which also allows the creation of a battery capable of producing safe, clean, abundant energy. So this may be a little bit inaccurate, but my understanding, and he can correct me once it gets going, my understanding of this is we're using the electric charge to interrupt or to destabilize the weak force in a nuclear material. And so the higher the voltage, the faster it decays. It's basically like a throttle for beta decay. And you can use that to take something like normally beta events create a trickle current, right? And like Bob Lazar has created batteries using a trickle current. So what Michael is talking about is basically creating a throttle for that so that you can take that trickle current and turn it into a battery. But everybody, welcome Michael McDonnough. And Michael, I'm going to spotlight you for everybody, sir.
Hey, folks. How's everyone?
Welcome back. I've got you on full screen. Just let me know. I've got the patents up when you want me to share those, and we're good to go.
All right. I think it's probably simplest to tell you how I got involved in this. I was looking at how are we going to power very, very small things and very, very large things once we have the capacity to, even if you can do a free energy device, it still has to get that energy from the vacuum into usable form. And it seems like storage, especially like in anything where you're drawing energy from nature, storage is important. Like with photovoltaics, with wind energy, with hydro, even, you know, on like micro hydro, you have a continuous amount of energy being given to you by nature, but you have to either build a machine big enough and send it down, down the grid like you do now, or you have to diversify the grid and do everything on like a battery level or in a storage capacity level. And so the sci-fi of our imagining when we were children isn't really practical in the real world. You know what I'm saying? I mean, it's like you can't like just turn something on and it just stays on forever. Like, it's like, for instance, robotics. You know, how many times do we have robots that have nuclear batteries? I think probably one of the worst ideas that I've seen in science fiction is giving a nuclear battery to a robot. Do you understand what I'm saying? Can you guys hear me?
Yeah, we can hear you fine. I just have everybody muted out.
Okay. All right, I'm sorry. But basically I thought about it and I was like, what do we want to give unlimited power to robots? And that was, I know that sounds silly, probably because of my sci-fi background, you know, that I thought of that, but I couldn't imagine doing, you know, tiny little nuclear batteries that would make nanoscale technology that could, you know, manipulate their environment to the point at the nano level that we'd cease to exist. And so I think that was probably one of the biggest reasons I was thinking, well, I need to go a little bit bigger than that. But it always boiled down to the point where if you do have free energy, or if you have even really long-lived nuclear energy, and you can get it down to the really small level, and then you have very, very intelligent micro machines that have the capacity to use that or to build it themselves, then we're in some serious trouble. But if you're familiar at all with beta voltaics, the beta discharge from certain isotopes is continuous, but it's relatively slow if it's safe enough to be in your hand. I mean, if you have a really strong beta decay or a really strong alpha decay or gamma, I mean, then now this thing is dangerous. I mean, however much energy you could get out of it isn't going to be worth it if you can't put it into an appliance that somebody could have near them. So, you know, the nuclear safety thing, and I think that's probably what shut down a lot of my funding capacity back in the day, was it was shortly after 9/11, and we were having some real issues with the Nuclear Regulatory Agency, with even just trying to get the idea of them putting us on a list to someday get our products approved if they were using any sort of a radioisotope, simply because if it has enough energy to be worth doing, then they're not going to allow you to have it in a device which can go on an aircraft. And every time I see like a commercial or so, I mean, not, but like a advertisement for somebody who is out there trying to get some money for a beta voltaic or any sort of a nuclear type of battery, whether it's alpha, beta, or, you know, whatever, if it has enough energy to be of use, then it's going to have enough of the radioisotope that they're basically going to say, no, you can't have this on an aircraft. So that was the reason that I came up with the concept for the stimulated decay. And then I was like, well, okay, well, if that's how I have to go around my problem of being able to produce a battery which can be used in devices which someone can bring on an aircraft or can, you know, have a license. And that's another thing too. Even the tiniest amount of radioisotope has to have a license. The little tiny amount of americium that is in a smoke detector, somebody had to have a license in order to just to manufacture that. And they had to manufacture it in such a way that it couldn't be concentrated easily into something that could be used as a dirty bomb or some kind of a weapon. So it was fraught with a lot of unanticipated problems that, you know, me being a younger man at the time, I didn't think of. I mean, I didn't have the experience. No one does. I mean, I had an idea. I wanted to see us have the ability to do things like lifters, you know, which need high voltage. And I thought, well, beta voltaics is perfect for lifters, you know, because I was in touch with the great Tim Ventura here. And, you know, I wanted to be involved in that. But in order for you to produce enough energy to motivate a lifter to get off the ground, you'd have to have enough radioisotope that it would strictly be illegal. I mean, there's no way you could possess that sort of thing. That's why, like in UFO technology, when I wrote, you know, the UFO Technology Hackers Manual years ago, one of the sticking factors was always, well, where's the energy come from? It either comes from a nuclear device or some kind of a free energy device. And so little is understood about free energy. Now a lot more. I mean, 17 years, you know, later, 22 years after I did that book, but about 17 years since I did beta voltaic. We have now the ability to do something like that, but that's brand new. So on the first one, I was thinking, well, how do I get a stimulated nuclear decay, either beta voltaic or whatever? So I started looking in the literature, in the patents, which I had become accustomed to when I started researching the UFO Technology Hackers Manual. You know, I sat in the library and and read microfiche, way before the internet, read microfiche on all the patents that had to do with electrostatic and electromotive force type of devices, everything from T. Townsend Brown, up to the more modern day stuff like, we've discussed in the past, like James Cox and, his dipolar force field propulsion engine. But all of those things required a tremendous amount of energy. And it just wasn't going to be possible without that capacity to be able to either speed up the nuclear decay of a safe isotope or have a very unsafe isotope and, be able to somehow put that into a device. But that got me a hold of first person I ever spoke to was Ted Gagnon. Ted Gagnon had a device which used a type of coil which looks just like a Mobius, like a Mobius ring. But he built a coil based on the Mobius ring, and he messed around with frequencies, pumping through the coil, and he actually did some really good research, which was had some good write-ups in it that I was able to find, where they took cobalt 60, no, excuse me, strontium 90, and they had a very small sample of strontium 90, and they put it in this coil, and he found frequencies that slowed the decay of the strontium 90. And he's using a sealed strontium 90 sample, obviously. I mean, it's the only thing you can put your hands on. And he put it inside this this Mobius coil, and he was able to reduce the the decay rate of that isotope. And so that got my attention, and I spoke to Ted Gagnon, and I think he has passed now. I have not been able to find any evidence that he continues to this day. Of course, that was a long time ago, and he was already a fairly old man. So, and I think he moved to another country because, he moved to China because he was doing some energy medicine work using that same technology, and they found that they could broadcast healing frequencies into biopolymers, and that those biopolymers, if they came in contact with people, they retained that frequency, and they had healing capacities. Anyway, he was trying to do that work, and so he ended up going to China so that he could do that without having a legal problem here in the United States or in Europe. So I lost contact with Ted Gagnon, and not wanting to just drop the whole idea, I continued to look around through the patent process, and I found first this patent, which you can bring up if you want, that is it uses a stimulated alpha decay, which uses a high voltage, and by placing the material to be alpha decayed, something that is already naturally alpha decaying, that you can speed up the alpha decay by creating a stress on the Coulomb barrier by placing the isotope near the negative on the circuit of the high voltage, and that would cause the positively charged ions from that to be able to move over quicker, and basically you get an alpha decay instead of so you got helium in your chamber instead of as much of whatever radioisotope that you were processing. And this was actually found out completely by accident by the Altran Corporation. The Altran Corporation, I did some research into them, and they were doing, and I believe they still exist. They were doing work at isotope enrichment at nuclear plants And I think their government contracts is what they were working with. They were doing enhancements of different types of isotopes using bombardment from the reactor, either through alpha decay or gamma or neutron absorption. That's what one of their primary focus of their government contracts was, in producing isotopes in the setting of nuclear reactors. So what happened was they ran a sample of uranium for enrichment to separate the plutonium and the uranium, and they ran it through an arc reactor. An arc furnace, not an arc reactor. That's a little Marvel comics there, but they were using an arc furnace, and what they found was they had losses during the enrichment process that they couldn't explain. So now they're in a position where, I don't know if you know anything about what goes on in nuclear facilities, but if you lose a pinch, a gram or a microgram of an isotope that could be enriched into like a weapons grade fissile material, then the whole place shuts down. Everyone gets inspected. They're going through and trying to find this little, piece of nuclear material that has gone missing, thinking someone's stolen it. Well, after the investigation was over, they realized that no one had stolen the isotope. It had gone through a stimulated alpha decay, because on the anode side of the arc reactor, I said it twice. Anyway, the arc furnace they were losing it at that side. They were finding additional helium in the gas flow. So there was no other way to explain it. They were having a stimulated alpha decay because of the high voltage affecting, collapsing the Coulomb barrier on the negative side of the chamber. So they patented it, and now they had a stimulated material. They now had a patent on alpha stimulation of nuclear material. Electrical stimulation of nuclear material to create a stimulated alpha decay. I had to get my words in order. That led me to, later on, Dr. Ruggero Santilli, which I believe you have also, you've talked to Dr. Santilli on your show, American Anti-Gravity. But he's alive. He's a good friend and was a good mentor for many years. And we helped him out financially to keep his patents going when he had some pretty tough times. I could probably work a deal with him, but his situation was he had found that by hitting a beta decaying isotope with a gamma of a particular frequency, I think it was 1.294 MeV, that he was able to cause a stimulated beta decay in particular beta decaying isotopes. I believe his target isotope was not technetium. No, possibly it was technetium. But anyway, in his experiments, he found that he was able to get a stimulated decay, and he has been awarded a patent. He was awarded that patent about a year after he and I concluded our business, but he was still doing business with some of the board of directors, like Leon, who was still helping to provide some money for his patenting process. But so he does have that patent, and his patent covers both the stimulated decay of the neutron in a beta decaying isotope, as well as the synthesis of neutrons from protons and electrons, which is that is the Rutherford, originally the Rutherford neutron. Now I believe they call it the Rutherford Centilli neutron model, where all neutrons are basically composed of protons that have absorbed one extra electron at a level where it is beyond the binding energy of just a proton and electron. So it's condensed. It's a denser form of a proton, which makes sense. If a stellar cloud collapses and begins to fuse, and the hydrogen has such a mass through the electrical discharge through it that it gains mass and then starts to develop neutrons, then you have the original hydrogen helium process of the suns. So starting from the Big Bang, if you believe that, then you have to go something beyond light, where everything is essentially composed from light, and then it's spun off or spun down, changes frequency so that it changes density, which corresponds with frequency. If you're a student of Nassim Haramein, which I am. But assuming that the beta voltaic process can be stimulated to decay, I thought, well, here's a chance, but obviously you're not going to have a device which you can put in your pocket, which can have a stimulated beta decay that requires a gamma photon to stimulate a beta electron decay. So we were hypothesizing with Dr. Centilli that a subharmonic or a higher harmonic, not a subharmonic, a higher harmonic of the requisite frequency would have a diminished but broader effect. In other words, like if a gamma photon can stimulate a beta decay, but then you could perhaps hit it with an X-ray of a higher but resonant frequency that that would also cause a decay, but perhaps it would stimulate a decay in a larger number of nuclei which were available at the cross section, that absorbed the X-ray. Anyway, so that was, but again, that didn't become something that was practical to do. So I continue to look. I'm blowing investors' money and my friends' monies and everything I've got, and we're trying to figure out some way to stimulate a decay. And so I'm researching the isotopes themselves, things that I wanted to figure out a way to stimulate the decay of. And I thought, well, a good one is going to be potassium-40. Potassium-40 has a pure electron with no gamma beta decay, and it also does a positron decay, which it does because of the way it's formed. Now that I have spoken to Ari Degas, who's no longer with us, Ari Degas had developed the idea that a lot of our atomic materials are, all of our materials are based on, smaller, simpler materials becoming more complex, which is obvious. Protons, extra neutrons, extra electrons are added so that you build up material. But it's not all done in the hearts of stars. As a matter of fact, a lot of what is in our physical universe was not made in the star, but was made in the outer portions of the star, in the plasma vortex currents that surround the star. What you see when you look at a star, through a telescope, through like instruments, satellites and such, is that there are huge filaments that are vortexes of plasma, which are continuously emitted by the star. So a lot of those mid-range materials are being formed in that layer. And the potassium-40, Arie de Geus had the idea that because of images that we had from satellites that showed the spectral lines of potassium-40 in supernova rings, that the potassium-40, his hypothesis was that the potassium-40 in our universe is generated in the vortex rings of supernova. That there is a particular frequency of the hydrogen plasma vortex, and its consumption of a particular bunch of the light elements like beryllium, boron, and lithium, which produces a lot of other elements, but it does that through the compression ring that extends from the vortex that is, you can see in, if you look through telescopes, we can see these huge rings of plasma that are emanating from these stellar explosions, from nova. So your supernovas are part of the process, but then de Geus figured out that he could reproduce that by taking these light elements. And as I said in our last conversation with the plasma vortex technology, he found that if you take a hydrogen plasma vortex and you bore into the anode on the plasma vortex fusion device, that it would, by binding the beryllium and boron, that it would be able to then synthesize other elements like extra hydrogen, extra helium, and of course the potassium-40. And we did find potassium-40. So I thought, well, now we found a way to not only synthesize something which is a hyperdense, very, very strong beta decaying isotope that has no gamma. It has a pure electron positron decay. And so that would be a good target for a device which you could put in your pocket, because it's using potassium-40, which I found out later. And I'm thinking, well, if we can synthesize it, then I can have as much of this potassium-40 as we need, because it's incredibly rare. Potassium-40 makes up, for instance, on Earth, I think I did a calculation a couple of days ago. I think there's roughly about 15.5 kilograms of potassium-40 in the entire Earth's crust, to give you an idea of just how little there is in the universe. Of all potassium, I mean, there's about 15.9 kilograms per per ton of crust that is made out of potassium, which is about 1.5%, I think. I don't know, my calculation could be wrong, but roughly 1.5% of the entire planet is potassium, and about 0.00017% of that is potassium-40. So there's an incredibly tiny amount of it, not just on this planet, but in the entire universe, because it was consumed in the formation of the universe to make all the other elements, mostly the ones that are between aluminum and nickel. Basically everything, everything iron, nickel, aluminum, all the ones in between there, sulfur, those are all produced outside of like, they're not compressed and, but made in planets. Like, we think of the heavy elements as being made inside stars or inside planets. But anyway, so here I am stumbling around, and I find the plasma vortex technology and basically a supply of potassium-40 isotope by being able to synthesize it from beryllium and hydrogen and a few other elements, which I'm not going to go into on this short of a broadcast. But it is it moves us one step closer to having the ability to have like starship level power. I mean, the energy density of potassium-40, even as rare as it is incredible. And it's without being stimulated. If it's not stimulated anyway, it has a half-life of like 1.4 billion years. So it's, ridiculously slow, to decay. And so if you have something like that and you got a lot of it, and then you can stimulate it on as required, I was thinking, this would be, until we have the ability to do matter antimatter, this would be close, for like Starship drive. I don't know. That's part of being a sci-fi person instead of a scientist. I think nothing is impossible until I come to the point where I realize, well, I guess it's not possible yet. So here we are. I've come to the conclusion there is no effective way to stimulate a decay of an isotope for beta decay in a way that would make it where you could get more out than you're putting in. For that, we have to go down the other direction to the nanoscale. And so that's where my focus has been over the last 4 years, 5 years, has been in learning about the electrical and nuclear types of weirdness that is available in graphene. And so that's been a lot of my focus. That got me interested in these guys that are now doing funding round for beta voltaics using diamonds that are made out of carbon-14. And I actually thought of that idea because carbon-14 is not that difficult to make. It has a pretty good neutron cross section. And so, nitrogen-14, when it's hit by high energy neutrons or cosmic rays, is what forms carbon-14 in our atmosphere. It's directly caused by the interaction of our nitrogen in our atmosphere, which is nitrogen-14 is like 99.97% of all nitrogen. It turns it into carbon-14. Carbon-14 obviously is what's used for dating. That's where most people are familiar with it. But carbon-14 is a very good pure beta decay isotope. And so it's one that's pretty safe. There's still some issues with it, like the company that's working on getting funding right now. They're probably only going to be doing like, getting contracts from In-Q-Tel, to do like, grain of, or not even that thick, like transmitters the size of a human skin cell or something, and it'll have a tiny little radioisotope battery in it, and they'll deploy them with aircraft or something, or drones, and sprinkle an area with little nanosensors, to for feedback into intelligence gathering systems. That was one of the things I learned when I was doing beta voltaic as well, is that there's a lot of interest in very, very, very tiny nuclear batteries by In-Q-Tel, which is the funding arm for the CIA and DARPA. they're interested in that kind of stuff. But you know, you don't have to have a license for that. I mean, you probably breathed in some you know, micro transmitter dust that with nuclear batteries in it today, just because there might have been some that was sprinkled in your area, you know, or was carried by the wind. And that's not a conspiracy theory. I mean, there's actually bid contracts that went out for that. Anyway, that's my rambling for the moment.
Well, Michael, thank you, sir. And that's a lot. That's a lot. I mean, you know, and again, so what I should share well, you know what? Let's do this. Let me put this bad boy on gallery view. I'm going to allow people to unmute themselves. Everyone, please give an enormous hand to Michael McDonough. Michael, thank you for returning. I see hands up already. So I guess I should probably preface this a little bit. Here, I'm gonna remove the spotlight for you.